talked a little bit about electrical forces, and today we're going to explore the relationship between the force and the distance of electrical forces. But we're going to use magnets to do this, to explore this, because electricity, we don't really want to play with that too much. You can get shocked. It's going to be very fun. So we're going to do a lab, and so in your lab notebooks, you need to write down, all the steps we've gone over the whole year. And what you're going to want to do is you're going to want to look at the relationship between distance and the relationship between distance and force. And so we have some equipment that you can use to do the lab. We have a magnetic field sensor, yardstick, a computer in Logger Pro, so that you can check your data. And so I want you to get together and come up with a plan for how you will use the equipment to find the relationship between distance and force. So collaborate. Cut. Turn the camera around.
Okay, so what do we have? There's the yardstick and the force probe. And can we use your computer?
Yeah.
You can put our results on the big screen. I don't care. Okay, Blogger Pro?
Yeah.
Okay.
It's down in the bottom.
Alright, so the question was to generate a conjecture on how we can determine the change in force based on distance using these materials.
Yep. And here's your magnets.
Okay. So we have magnets. And when you bring them closer together, you can feel the force is stronger. So we gotta figure out how to use this to measure it. What's stronger sometimes, like depending on what end we're using. Oh, okay. So the try not to know too much. So when the poles are the opposite, it looks like they attract. Okay. I guess maybe we should take some masking tape and like measure out certain distances and see if we can measure different depths, different widths. So this is a magnetic field sensor. So I'm guessing like fields related to force. So if we can figure out like the magnetic field, should we do like every inch or like every 10 centimeters or something? To every 5 centimeters? 1 centimeter? 5 centimeters. Okay. Maybe? Or maybe every inch? Let's do every inch. Okay. Seems like good. Okay.
And then you'll want to remember to make sure you calibrate your sensor and everything, so your results are good.
We just have it be continuous. Yeah, I want to take like more from okay, so let's go for like the
Notice that you have two different types of magnets, so you can play around with that and see if one magnet, if there's a difference between the magnets.
actually, I should put them all on there and then zero out the probe. Right. So now it's not near anything magnetic. That's pretty standard. And then we're going zero. So what do you want to do? Do you want to bring like have one magnet at this end? Should we do the other magnet? Should we do the way that it repels, or should we do the way that it attracts? Which way do you want to do first? I don't know.
So the sensor just picks up the magnetic field?
Doesn't matter whether it attracts or repels?
No. So you might want to just tape your sensor to one end and move the magnet the sensor, or put the magnet, tape the magnet down and move the sensor.
I get how it works
So
now.
let's put it here.
So this has a
Yeah, so it has
magnetic tendency to it. Okay.
it.
I thought it was like that we could like stick it in the middle and then we tell
That's
us.
still basically 0.
No, it doesn't work.
So let's do one of each of the kinds of magnets. So we'll do this one and then we'll do the little one.
So let's see what happens. Do you want to start it
So
out?
12 inches, press collect.
Oh, okay.
Okay.
No, this is.
Actually, maybe continuous is the best since we have discrete places we're gonna move it to.
Okay, so I can
Stop it.
and then
So we can take the average of that. It's like what, 0.299 something.
so
Do you want me to do that as we go, or? Yeah. How about I just write it down real fast?
okay.
So we were at 12 inches and it was like 0.3. Is that the average?
From 0.27, I can give it really quick.
Okay. Great. How much time do we have?
To finish?
Yeah. Because I can make this lab take a long time.
Don't pay
You're-
attention to that, Heidi.
You're doing good.
Okay.
We just want you to be able to understand the concept of what happens as you move the magnet, as distance increases between electrical forces.
Okay.
And the relationship is the same with magnets as it is with electricity. So hence the magnets, they're a little safer to work
Safer
with.
to play. Okay.
Unless of course you have like a pacemaker or something, then you might be in trouble.
Yeah, that's like the first one.
0.0265 at 12 inches.
All right, and then moving it up to 11. We can hit collect.
Can I check those first, or?
No, we'll just do a new one. No, 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 yeah.
Is that good enough? Or
Yeah.
should I go on?
I don't know what that weird dip was. Can you not collect that dip? I think that's 20 points.
And as you're doing it, think of things that could interfere with the data that you're getting. So you can
Okay, 0.0251.
That's weird. It got smaller. All right, 10 inches.
Maybe I'll try and collect for a little bit longer.
Okay.
Like 5 seconds.
It should be pretty constant. That's probably good. If we were smart, we would be able to figure out like a way to tell it how distance it was in there and just plot it on that curve. Like
Yeah.
1, 2, 3.
0. 1, 2, 3, 0. So I wonder why it's getting smaller.
I think it's backwards. When I did it, it goes.
So magnetic fields are pointing either towards or away.
Oh, so it's going the opposite direction.
Yeah.
But it'll give you the relationship will still.
So what
work.
if I put this magnet here by the probe, and then we know that there's the force because the field lines are like drawn in between them, right?
But wouldn't the probe pull from the side?
Yeah. I'm just wondering if that would like strengthen the magnetic field here because there's two magnets instead.
I'm not asking the hypo questions.
I'll keep it away. I'll be nice. Okay. 9 inches?
I don't know the answer to your question, by the way. But I do know cow magnets. They have funny magnetic fields.
Uh-huh.
So, because
Yeah, they're not like bar magnets.
they have a magnetic field that goes
Circular.
circular around them.
Okay,
So
wait,
that would be-
0.0215.
Alright, okay, we are getting to just I'm gonna move it up to 6 inches.
Okay. Ready?
Mm-hmm. So when I brought the other magnet close, did I just warp the cow magnet? Is it not a permanent magnet?
Cow magnets?
Yeah.
They're permanent.
They're permanent, okay.
Okay, wait, 0218.
Okay, and then 3 inches.
Man, it's getting fussier with it being closer.
Huh. Like all the little dips.
Yeah.
Well, I could have come at it sideways.
0230.
Okay. And then we'll do 1 inch for the foot.
So what are you noticing about the data points that you're getting?
So the closer we get, the magnetic field gets smaller.
It just got really strong.
Except for 1 inch, because it's weird. So maybe the probe only works.
0.265.
So that's 10 times more. But if we did half an inch, would it be as strong or twice as strong?
Is that half an inch?
Yep.
So I wonder if maybe something else was interfering
I don't know if the magnet's away.
far away, because look how it's now at point like 3 something.
Huh.
Can you do a 1/4 inch?
Yeah.
Okay, let me do this one. 0.333.
Okay. It's a 1/4 inch now. That kind of makes sense though, because the magnet was super weak, like when it's very far away. And it's only when you get the other like when the magnets are super close to each other.
That one didn't change very much, so it's
Okay.
0.333 as well.
Right, because I can put this magnet 12 inches away and there's no apparent force between them.
Right. Do you want to do the little one?
Yeah, I
really
want to do the
quickly?
little one.
And start maybe at like 3 inches each
Uh-huh.
one? Okay.
Mhm.
Ooh, that one doesn't have very much at all.
Well, what if I turn it around? Okay. Try that.
That's
That's
better.
sideways, alright. I'll leave it sideways, that works.
That was like something that's actually worth something.
Okay.
Before it was like 0.00.
So is this one a bar magnet? Does that count? Is it coming in the field that's coming out along the axis and then around?
All magnets do that, but
Well, these don't.
Okay, 0.177.
Okay. And then do you want to do 2 and 1?
Sure.
Yeah, stop rolling. Alright, we're good.
Ooh. That's a good jump.
Yeah.
so is there a difference between the magnets?
Yes. There's a big difference between the magnets.
Why less than
Sorry.
0.3.
Okay. And we'll do 1 inch and we'll call it good.
All right. Well, might have been some experimental error in that one.
Alright, let's redo it real fast.
Here we go. Oh, it's 30 there. Got it. Okay. 0.333.
Okay. So on both of them, there's kind of like this limit of the maximum the probe measures.
Yeah.
They both maxed out when we got really close.
Okay, so now what can you do with the data points to find the relationship between the distance and the strength?
We can graph them.
Very good.
Yay!
So,
Can you just use computer? Sure. Alright.
Or you can use longer probe.
we didn't say data. Just
So let's just do the data for like,
like 3 inches and over.
yeah. So I'll do 1, 2, 3 inches, and this is field.
Oh, and that's 15 minutes.
Woohoo!